So we're going to review some of the undoing operations we worked on last week. I know you haven't done it before, sir, but Romana's an excellent teacher. She'll be able to show you how to do this. So go ahead and copy down this, just what's in the box, along with the box and the line so that we can describe these operations and then undo them. First, if we knew this number x, because that x is something we don't know. It could be a secret number that I picked, just one we don't know. So if I picked a number, but we knew what it was, what would be the first thing I would perform on that using the order of operations? First operation I would do to that number right there. Subtract 5. Okay, so after we picked that x, after I picked it, the magic number, underneath it, we put the subtract 5. Okay. And the next operation we would perform on it. Times 4. Yeah.
So we got multiplied by 4, and so what would be the third step here before we actually arrive to the answer to 12 here? It's fresh on your mind, isn't it? So we got, boom, right there, divide by -3. Okay, perfect. And so after doing that, what would be the result? What does it equal? There you go, you got that, right? Perfect. Now, if we were to, okay, so if we were to go back, if we know the answer is 12 and we undid it, what would be the inverse of operation of dividing by -3? Oops. We would have to do, obviously the undoing part of it would be, we would have to do, instead of subtracting 5, we would have to do what?
Add 5.
Good. And then instead of multiplying by 4, we would what?
Divide by 4.
Good. And then if we were, instead of dividing by -3, you would what? Times -3. Okay, good. So let's kind of go backwards and work that out. So if we did 12 times -3, what would we get? If we did that on the calculators. Did you already do it or you already know that? Okay, so it'd be -36, right? So if we did -36 and we divided by 4, what would we get? What was it? -9, right? Perfect. And so if we had -9 and we added 5 to that, what would we get? -4. So basically, by kind of going through the operations and then undoing them, we know that by having answering the 12 and then arriving at -4, that we know that if we plugged it back in for x, will we get 12 at the end, you think? Do you guys remember if we did that? Pull out your calculators real quick. I just want to show you guys real quickly. Turn on your calculators. If you forgot how to do that, you hit on in the bottom left. So put in -4 in place of x. So put -4. Subtract 5. And hit enter after you do that. Okay. -9, right? And then what's the next step? Times 4. And then hit enter. And then what's the last step? Divide by -3. Is that equal 12?
Yeah.
Perfect. You guys got it. So,
There we go. Secret number. Awesome.
there we go.
So let's go ahead and try another one. You have these boxes that are already made for you also, if you want to go ahead and use those ones. So yeah, let's go ahead and operations in the order of operations, if you knew what this number was. I'm going to share the description, see what you guys got. You get easy operations. Okay. Subtract 1 times 12 plus 4 and divide by 5. Okay. And to undo those, what do you guys have?
Plus 1.
Plus 1?
Divide 12. Minus 4. Times 4.
Alright. Oh, sorry. The result. Okay, the result when we did all that was the 2. But see? Okay, that all matches up. And then when you perform this on all of those. Okay. So, check that with yours. Did you get anything different? Juanita, was there something possibly different you could have gotten? 2 for the third one? Okay. Second one. The This one? Oh, second from the top. Okay, so 2 times 5, 10. And then what's 10 minus 4? 6. Okay, 6 divided by 2? 1 half? Or is it 2? 2. Okay, so if you have 6 things, give me 6 things that you can share. Mr. Rumble and I were talking about this. We're big on food. So we were like, yeah, man, we would love to have like pizza or something. So if you had 6 pizzas and you have 12 people to share with, how much of a pizza does each person get? Half a pizza? Okay. If you had 12 pizzas and you were sharing it with 6 people, how much does each person get? 2. Okay. So if these were switched, we could do, it would probably be 2, huh? So then we have the 1 half plus 1. Now I'm thinking it's 1 half a pizza plus a whole pizza. How many pizzas? 1 and a half pizzas. Okay. All right. I mean, it could be either way, right? Are these the same thing? 1 half and 1 and 5. Okay. So we did one kind of like this last time. This one might need to draw or make copies. Yeah. All right. We did this one last time, but or not this one, but we did one similar. We kind of talked about this issue with subtraction to see if we can make an easier one to work with, because that one messed a lot of people up. So take a look at these expressions. Okay, find out. Do that. Can you do that one in your head or on a calculator? That's fine. Okay. How about this one? What's the value of this expression? They don't take pictures, but you can do math.
This one is 1.
Okay. So this one's -4 and this one's 1. Let's see. So -5 plus 6.
1.
1. Positive 1. Positive 1 times 4.
4.
4. And 3 minus 4.
1.
-1. Yeah. -1. Okay. How about this one then? -5 plus 6 is still 1. 1 times -4.
Negative.
-4. So -4 plus 3.
1.
1.
This one.
-4 plus 3.
Negative 1. Yeah, it's 3 positive. 3 negative.
So is it positive 1 or -1? I didn't hear you.
Oh, that's -1.
-1? Okay, because there's more negatives.
Yeah.
All right. So these are the same, but what's different about these two expressions? Which part is positive and which part is negative? -4 and +4, huh? Okay, what happens when you take away hot cubes? What happens to the temperature?
It's cold.
It gets colder. Hey, well, you're gonna be my expert. I can't believe I'm listening. All right, it gets cold when you take away hot cubes. How about when you add cold cubes? What happens to the temperature?
It's cold.
It's cold. All right, so both of them are doing the same thing, right? Can you write this expression, please? You have line paper without subtraction signs. Like we saw that subtracting a +4 was the same value as adding a -4. So I think a lot of people chose to, instead of subtracting a +3, adding a -3, and same with the 9. Instead of subtracting a +9, they're adding a -9. I really liked the way that Sammy protected those negatives with the parentheses, because this can get confusing or get entered into the calculator as a plus subtract. But she put the parenthesis around it to say that specifically is the -3 and the -9. Yeah. So there's multiple ways to write it, but it all should come out to the same value. So based on that, see if you can complete this one on the sheet that Mr. Rumbo just gave you.
Just give you guys a new one, so you guys can write on the new paper that I just passed.
there a way that we can convert this so that it's easier to work with? Can we change any of those signs in there?
-3.
To what? Oh, wait, no, it says it's a positive 3. Wait, what are you talking about?
Oh, yeah, +3.
So change it to a what?
-3.
To a -3? Hold on a sec. Does that look like what you're talking about?
Mm-hmm.
Great job. I mean, you guys are all amazing at this, so can I get a volunteer? I can't choose. Can someone volunteer to write some stuff up here, please? Okay, well, it's your last day. Oh, Romana, come on up. You can bring your paper.
Hey,
Fill in
your
this
last day
description
too?
part, please.
Yeah. Awesome, man.
There you go. Fill in what you got for that description. Please check your answers with Romana. Actually, check Romana's answers, because I don't know if she did that part right. Okay, you can leave the marker up there. I'll get someone to do some undoing for us.
There's enough boxes on the screen, but there's not enough boxes under.
Not on other paper, no. You guys agree with those? You agree with those descriptions?
Do you agree with yourself?
Okay. Abel, do you mind filling in the undo column, please? What's that? Alright. Do you guys agree with those undoing operations? Feel free to speak up. Let us know. Abel needs to know if you did it wrong. Okay. And can I get someone to fill in the result column? Let's see if we got them all right. Boom! Match up?
They do.
You guys are champs.
And they did it to the left of the numbers.
I know, I
That's nice.
did it conveniently. I'm impressed with you guys. Alright, so it's gonna mess up the next slide though. So, great job. You guys are experts on undoing operations. +8. Next one. I got mine. Good, sir.
Okay, guys, we're gonna kind of switch over to today's lesson, which is recursively divine sequences. So 3-1. And Juanita, you've been in New York, haven't you? Right. Where's the Empire State Building? Is in New York, obviously one of the tallest buildings there. And as you guys know, it's 102 floors high, and it's got 1,250 feet high, actually. So there's 102 floors, 1,250 feet high. Okay. So how high are you when you're on the 80th floor? We try to figure that out. Okay. So we can actually use a recursive sequence to figure that out. So we could solve this with a recursive sequence. So basically a recursive sequence that means that there's an ongoing operation that's added or multiplied continuously over and over again to get a result. So what we can do is we can start with a number or a value, okay? And then there's a rule to get to that next number, okay? So if we have x, we would do something over and over again. So we multiply by 3, or multiply by 1.5, or divide by 2 to get to that next level. So it's recurring over and over again, repeatedly until we figure out what the sequence is. Okay? So a term is one of the numbers in the sequence. So we'll figure that out by using the table names. Okay? So the table shows heights above and below ground at different floor levels in a 25-story building. This is not the Empire State Building. Okay? All right, so we're going to write a recursive rule for the sequence of heights that corresponds to the building floor numbers. Okay? What is the starting value of the height? If you look at the table, you guys notice, what is the starting height of that building? Frank, what do you think?
4 or -4.
That's exactly right. So we have -4, right? Do you guys agree with that? Or do you guys what did you guys initially think of at first? Did you guys think of 9? No? Nobody thought of that? I thought some people usually pick that one first. But negative 4, because actually the basement is actually the first floor if you think about it. And then from there, we go 1, 2, and all the way up to the highest floor, and then obviously you got an elevator to go down, right? Okay, so the height on the value of the first floor is negative 4 of the basement, right? Okay. How do I go from one floor height to the next? What's going from basement 0 to the next one? What is it going up by? What is it? So if I go from negative 4 to 0, it's how much? Positive 4, and then from 0 to 9. So it's 4 plus 9. It's 4 plus 9. Or 9 plus 4. What is it? 13. So from here to here is 13, okay? And so we have adding by 13. So our rule is adding by 13. So we have the starting value, and then we're adding 13. So if we go from 9 to 22, if we do 9 plus 13, is that 22? So what we're going to do is we're going to use this rule and your calculator to find each missing value in the table. Okay? So what I want you guys to do is I want you guys to use your calculator. So go ahead and turn those back on. And I want you guys to have your starting value of negative 4. So type in negative 4 first. Okay? That's all. Okay. And we have to hit enter first, right?
Yep.
Okay, hit enter first. Hit enter on your calculator next. Okay. And then what we're going to do is, since our recursive rule is what were we adding by? First, we want to add 13 to that. And then hit enter. So we have 9, right? So I want you guys to go ahead and hit enter about maybe 3 or 4 times. So hit enter 3 or 4 times. You don't have to keep hitting add 13, you can just hit enter and it'll give you 4 sets of values there. Okay? Alright. Do you guys have these values?
Yeah.
Okay. So our recursive rule is adding by what? 13. Adding by 13. Good. Alright, so let's figure out some terms in the actual what's the next height in the set of sequences here. So we already know that the recursive rule is adding by 13. What's going to be the height at the 4th floor?
48.
Good, perfect. Now what about 10? How would we figure out 10? The 10th floor. What would our height be? What would we have to do? What could you do on your calculator? Adding 13, so or what's a shortcut of doing that? Okay, we already know that the rule, the recursive rule is what? Adding by 13, right? So if we want to, we already know the height of the 4th floor, how do we figure out the height of the 10th? Don't you have the first 4 heights of the building? So how do we, try hitting enter one more time. Okay. So that would be the height of what? 5, and then we would hit enter again, and what happens? So this is 0, 1, 2, 3, 4, hit enter again, 5, hit enter again, 6, hit enter again, 7, and go all the way up to 10 to see what you get.
Can we
Did you
just,
get 10?
do
Where you are on 10?
You could, but just hit enter again. What would be the height of the floor at 10? Is it 126? What'd you guys get? 26. Okay. So it is 126. Now on the next one that they actually don't, we actually have the height of the building as 217, but we don't have the actual floor number. How would we figure that out? What could we do? Good. How would we figure out the height? If we knew that the height was, how would we figure out what the floor level is? You think it's what? You said 17?
Check that.
How did you figure it out?
Oh, no, we can start over.
You guys can start over or go arrow up to count how many levels you're at too. Try that on your packet. So you got 17. It seems like 17. 217? We have 217, but I need to figure out the height or the floor level here.
That's 2.
You can just count
No,
how
that's
many
1.
levels you want and see what that would be. You get 217 here, right? So then what'd you get?
Okay, so there's 4, 1.
Okay, 217, so what floor level would that be? 3. So Savannah got 17, what did you guys get? Okay, so we're actually figured out what the floor level is 10, right? And we got 126, okay? And so now they give us the height, but we need to figure out the floor level. How many times we've entered in your calculator,
Do
right?
you remember where you are? Okay.
Keep going. You get 217.
Remember, did you, what?
And so how many times did you get enter? Yes, there you go, 17, you actually did it 17 times. So the recursive rule, we can go on forever, couldn't we? We can go on forever for infinity. So we know that the recursive rule is obviously adding by 13.
What did we start with? Where did we start? A -4. It wasn't like the basement or the floor was at 0, right?
Right.
We're on the ground. -4. And what's the top height of that building?
Okay, so now that we have the last one here is 25. So how are you going to figure out if there's the floor number is 25? How am I going to figure out? How am I going to figure out the actual height of the building there? Okay, so hit enter a few more times.
Okay, well that's the
What did you get?
Keep going.
Do it.
Hit enter.
Do it on your calculator. See if you can figure out what the height of the building is by entering a few more times, so you can get 321. 321.
That's the 25th floor.
Okay, good. Nassim, what did you get? 321. All right. Bingo. You guys got 321. So the recursive rule is true by adding by 13 every time.
But we had to start though. If we started at 0, it'd be something different, huh? Well, what did we start with?
Start with
-4. Right.
awesome. Very good.
Let's look at a pattern of toothpicks. You have it on your paper, but take a look. Figure 1. Figure 2. Change. And now figure 3. Look at how they're changing. They're growing. Okay. So first I want you to look at that pattern and see how it's going, and then draw the first 6 of those. What would the first 6 of them look like?
Okay, so we have figure 1, figure 2, figure 3.
Draw.
So
the first one, you can just, we don't have toothpicks, so let's draw first one, second one. How would you describe this pattern? How would you describe the changing that's going on? Marcos, what's happening each time? Adding? True, they're adding more to the. Can you describe, like, how many more?
7.
Like 2 more each time? Okay. What shape is that making every time they add
See
it?
a pattern in triangle?
A new triangle? Yeah, off the side? Okay. So we
it's
saw
a
that
set, how many
when we
also
add
have?
2 more toothpicks,
Now draw.
we saw when we added the 2 more toothpicks, it looks like they are adding another triangle. All right.
So you don't.
Do you guys know what the perimeter is? Perimeter of something? Someone have a definition for perimeter? Perimeter is like the outside, okay? The outside. So, what would be the perimeter of this one? 3. How do you get 3?
Because it's 3 toothpicks.
3 toothpicks. So 1, 2, 3, right? Okay, 3 toothpicks. How about this one? What's the perimeter of this one, Savannah? 4. 1, 2, 3, 4. How come this one's not part of the perimeter? Because it's inside, and you said perimeter is outside. Okay. How many toothpicks did it take to make this one? How many toothpicks did it take to make this one? 5? 5. Okay. All right. So let's record that data in that chart that it gave us. I think it's on step 2. It says figure 1, how many toothpicks to make it, and then figure 1, what's the perimeter?
So what's the?
Same with figure 2, how many toothpicks to make it, and what's the perimeter? Figure 1, how many toothpicks did it take to make? 3. Okay, how many, what's the perimeter in toothpicks? How many? 3. How about on figure 2? 5 to make it? And what's the perimeter? 4. Okay. Nice kids. Number 10 would be probably, well, depending on the size of your toothpick drawings, would be too big for this paper, right? To find this 10th one, like I need to give you a full-on like blank sheet of paper. So forget that. Let's see if there's a faster way. That's what we try and do in math. We try and find a pattern that'll help us get there. So what are we doing to find out what the 10th one is? What do we start with? 3. And what did we do each time? Add 2? Start with 3 and adding 2 each time? Okay, so if we put like a 3 into our calculator, I wish I had a graphing calculator somewhere, anywhere that I could just press a 3 and press enter, but I don't. Does anybody have a graphing calculator? They can press 3 and press enter, and then plus 2? Anybody? I think it's right there, Sammy. That one. You can use that one. Frankie, can you press a 3 in that calculator right there? And press enter, please. And then plus 2. Because Abel said we're going up by 2. Do you guys agree with that? Is this going up 2 each time? Yeah. Okay, so let's try and get to that 10th one without drawing. So let's just press enter a few times. 10 times. So see what we're at on the 10th one. Let's see how our calculator skills are.
We know that the last number that we did was 13. That was the what figure was
The
that?
second one, huh? Third,
So that's 7, 8,
4,
9, 10 right there. So what's the number of sutrans? Okay, good.
So let's check our calculator skills real quick. Just throw out what number did you get when you hit it, or you got to the 10th one. Go. What is it? 21. There's some people that are like 21, 21. Did anyone get 23? No. Did anyone get 19? No. Okay. That just has to be me bad counting and pressing enter too many times. Okay. Well, great job. You guys are pros at recursive routines. What was the recursive rule for this? What was the recursive rule for this thing? So first we have to have a start with, and what's the rule or the thing we do to get to the next term? Start with 3, then no. What? Start with 3, and then what did we do?
Add 2.
Start with 3, add 2. Start with 3, add 2, and that's in calculator talk, huh? This is like what we do to get there. Oh, I think is this like one of the questions on here? Oh, I'm sorry about that. Yeah, step 3, guys. Step 3.
Move it over
You're
to
telling
the
them.
Move it over to the dice.
Yeah, it's on the. Okay, so we start with, that's how we find the number of toothpicks. What's a recursive rule that will help us find the 10th one of the perimeter? Start with 3, and then are we adding, subtracting, multiplying, dividing, exponents? What are we doing each time? Start with 3, add how many? 1. Okay. So what's the 10th one? Start with 3, add. Start with 3 again? 3 enters? Yeah. Plus 1. Yeah. Okay, so that's the first one. Second one. Keep going. Third, fourth. Okay.
Start with 3,
6, 7, 8, 9, 10. Wait, which one was it? Oh, snap.
It's there.
It's there? Which one? 13, 12, 11? I don't even know.
Sorry.
Okay. So me and Frankie, we pulled what I normally do is I try and count and then I get distracted by something like shiny light or something. And we got like 11, 12, 13, somewhere in there. Can you guys, what'd you get, Marcos?
What?
For the 10th one on the perimeter.
Oh. 10th one?
Or Romana, yeah, whoever. Yeah, what'd you get for the perimeter of the 10th one?
Oh, 12.
12? Okay. What'd you get? 12, you sure? Okay. What do you get, Sammy?
You guys gotta be on your toes, you can call it anytime.
Yeah, on this one. Yeah. The one below. 12. Okay, so we got 12, 12, 12. I got 13. I'm probably wrong. What'd you get, young lady? 12. Okay, I'm gonna go with it's 12. You did that with recursive routines?
No.
No.
The answer is
Okay, what'd you get?
12.
Because you got it from your neighbors?
No, I had it first.
He had it first. Okay, like this one. Let's see what our recursive routine was then. Start with what?
3.
And then what do we do each time?
Add 1.
Add 1. Start with 3, add 1. This is in English. This is in calculator, right? 3, enter. Our answer, our short answer plus 1. Over. Awesome. Okay. You still have that line paper? Please find the missing terms and write the recursive rule that you use to find those missing terms. All right, let's check our answers with the board. So, we have these ones missing. 7, 12, 17, 22? Yeah. We have 32?
Yeah.
37 and 47?
Yeah.
All right. What was the recursive rule?
Start with 7 divided by 5.
Add 5? Okay. I got it from 2 people. I'm going to trust it. Oh, and the board says start with 7. All right. Next one. Let's see. Check your missing numbers. 7. See, what are we doing?
Subtracting 4.
Subtracting 4? So 1 minus 4 is? 1 minus 4 is what?
Oh.
Negative 3, okay. How about negative 3 minus 4? Okay. Alright, is there another thing you could do? What's happening to these numbers? They're dropping. Or they're getting, what were you saying? They're getting bigger, but they're getting more what? More further into the what?
Cold.
Cold, I like it. The cold. What's the cold numbers? What we used to represent cold temperatures?
Negative.
Negatives, alright. So 2 ways that we can make cold, right? You guys said subtract 4, so take out hot, but we could also be doing what?
Putting in cold.
Putting in cold, so we could be adding negatives. So, see, this one, we could subtract 4, or we could be adding
Negative.
-4, right? Awesome, or negative. Awesome. What about this one? This one gets a little crazy. Minus -2? Times -2? What did we start with though? 2. Start with 2. Multiply by -2. Alright, so 2 times -2 is -4. What about -4 times -2?
8.
8. So we're removing bunches of cold cubes. If you remove bunches of cold cubes, temperature gets hotter. Oh, hotter. Okay. So started with 2 and multiplied by -2. Okay, good job. Or divide by -1. So, we're on to some textbook work. All right, get those passed out. You guys are experts at this. I think it's going to go really easily for you.